Hi, this video is for Nova Online Math 161 and we're looking at section 2.5 and we have this quadratic over linear rational function where we have to find all asymptotes. So let me read the function. F of x equals 3x squared minus 5x plus 1 over x squared minus 7. Well, in fact, this isn't quadratic over linear. This is quadratic over quadratic, right? So, first thing that we notice is that the degree of the numerator and the degree of the denominator are the same, okay? So remember, for those cases, you can find the horizontal asymptote. You can find the horizontal asymptote by taking the ratio of their leading coefficients. So you have to take the ratio of 3 and 1. What is 3 over 1? Well, that's just going to be 3, right? So we have a horizontal asymptote at y equals 3 for this function. And this rule works if the degree of the numerator and the degree of the denominators are the same. So if the biggest exponent on top of the fraction is the same as the biggest exponent in the bottom of the fraction, simply divide their leading coefficients, and that's going to be the horizontal asymptote. So we found it, okay? Now, if it has a horizontal asymptote, it's not going to have a slant asymptote. So the next type of asymptote we can find is the vertical asymptote. Vertical asymptote, we have to be careful. Sometimes, if it cancels out, then it's going to leave a hole in the graph instead of a whole vertical asymptote. So what I'm going to try to do is see if we can simplify this rational function at all. Because if it doesn't simplify, we're going to jump into finding the vertical asymptote. So I'm copying this over here. And I'm going to look at it. Now, nothing cancels out as is. But is there anything we can do to factor the numerator or the denominator? Now, I'm not sure. Maybe the numerator is factorable. Maybe it is. But look at the denominator. Is there a way to break down x squared minus 7? I don't really think so. If this was x squared minus 9, then we can do the difference of perfect squares. But I don't see any way to break this denominator out or factor it out so that we can, cancel anything out on the numerator and the denominator. So nothing cancels out, okay? So what we're going to do is to find the vertical asymptote. We're going to set the denominator equal to 0, okay? So anytime you want to find the vertical asymptote, this is to find the vertical asymptote. Try to simplify it first, okay? And I wish I can give you more examples where things actually simplify and cancel out. If they cancel out, you're not going to say those are vertical asymptotes. But if it cancel out, you're going to call it HOLE, a hole. But because nothing cancels out in our particular problem, we're just going to set the denominator equal to 0 and solve for it. Watch, I will add 7 to both sides. Then I get x squared equals positive 7. To get rid of squaring, let's take square root of both sides. But when you do that, you will have to put plus or minus sign in front of that square root of 7. So this graph will have two vertical asymptotes. One at positive square root of 7, and the other one at x equals negative square root of 7. So we did it algebraically, we did it by hand, but I want us to check this graphically on a graphing calculator, even though you're not allowed to use a graphing calculator on your exam, as we are practicing this, as checking it with the graphing calculator will be a good way to see if we did it right, okay? So watch. I'm going to do f of x equals a fraction bar, 3x squared minus 5x plus 1. And I'm going to go to the denominator and type in x squared minus 7. I am going to plot or graph the horizontal asymptote at y equals 3, okay? Well, I shouldn't say Okay, I'm going to use a dotted line to do that. And then I'm going to graph two vertical asymptotes of x equals square root of 7 and the other graph of x equals negative square root of 7. And I'm going to use dotted lines to mark those, okay? All right, all good. All right, I'm going to zoom out and show you this image, okay? So we have, I think the vertical asymptotes definitely fit, right? So these two black dotted vertical lines are cutting the graph in 3 pieces. Now I said, uh-oh, because I was a little worried about the graph crossing the horizontal asymptote right there, but that's okay. Horizontal asymptote is the horizontal line that the graph follows to the right or the left extreme. Okay, so we're looking at the right end behavior, left end behavior. They're not really particularly worrying about what's happening in between. Okay, so look at the right side of the graph. If I keep on following this graph to the right, notice this graph is getting infinitely close to this purple dotted line, right? So yes, that is the horizontal asymptote for this function. It's okay if it wants to cross it in the middle, okay, somewhere in the middle. As long as the graph is getting close to that dotted line, we do have a horizontal asymptote at y equals 3. Now I go to the left side and I notice the same thing. You see that green graph is getting infinitely close to that horizontal asymptote at y equals 3. So yes, this graph does have a horizontal asymptote at y equals 3 and 2 vertical asymptotes at x equals square root of 7 and negative square root of 7.